Hey guys, my name is Sophie George and I'm an environmental scientist. Today I'm going to do a presentation on the mining cycle and the final part of the cycle, rehabilitation. I've been asked to do this presentation for some Year 10 STEM students in Mackay, but I thought I'd put the recording up here for anyone else that would like to have a watch and a listen. So I am an environmental scientist majoring in integrated land and water management. And I am now completing my Bachelor of Science Biology, and next year I will complete my honours degree. So before we begin today, I would like to complete an acknowledgement of country. I would like to acknowledge the traditional owners of the land on which we study, the Darumbal country here in Rockhampton, the Wapabara country out on our coast, and in Mackay, the Yuwi country. I pay respect to the Darumbal, Wapabara and Yuwibara elders, past, present and emerging, for they hold the culture, the memories and the dreams of the Aboriginal and Torres Strait Islander people. This always was, this always will be Aboriginal land. I would also like to acknowledge, when I am recording this, that it is actually NAIDOC week. The theme for this year's NAIDOC week is Get Up, Stand Up, Show Up, where we celebrate the history, culture and achievements of Aboriginal and Torres Strait Islander people. Now, as an environmental scientist, it is extremely important to me that I always acknowledge our traditional owners, for this is their country, not mine. This is their land, not mine. I'm here to heal and to help, but I honestly believe that all management decisions should be made by traditional owners. This is their country, they know it best. There's 80,000 years of knowledge. I cannot even fathom or compare to that. So it is so important when we are healing country, we're making decisions for country, we're rehabilitating country, that we always have our traditional owners involved, especially in the decision-making process. So in this session, there is going to be a quiz at the end. So when I did this with the STEM students, they took notes and we went over the questions at the end. So we'll have a look at those questions, but usually you would have your questions with you while we're going through this presentation. The main thing we're going to learn about is what is rehabilitation and what is restoration and why they are important. It is important to also understand that there is a lot of environmental law around mining rehabilitation, and that all mines will have what is called an EIS, or an environmental impact statement. That would be a whole presentation on itself, and very important to that EIS is also the cultural heritage impact statement, the Indigenous Land Use Agreement, the Reconciliation Action Plan, which are all very important components of the EIS, as per the environmental law surrounding mine sites. And for those STEM students, and for any students watching this, remember that you are the future of mine site rehabilitation. You are about to learn that it takes a very long time to rehabilitate those mine sites. So it's actually the kids in high school today that will be seeing the outcomes of the rehabilitation practices that are happening right now. So everything that we're going to learn today has come from my Bachelor of Environmental Science degree, in particular the unit Mining, Urban and Industrial Lands Rehabilitation. Now this unit is provided by Ashwa. Professor Ashwa works here at CQU in Rockhampton. We are incredibly privileged to have him at the university. He is absolutely one of the leading scientists today in landscape rehabilitation. Ashwa provided this textbook for us to read, Restoring Disturbed Landscapes by Tongwei and Ludwig. It is an essential, it is my Bible. It's so easy to read, it's cheap, it's little. Anyone that wants to restore anything definitely needs to go and check out this book, not just for mining, but also for rangelands and agriculture, landfills. I absolutely recommend reading and getting a copy of the textbook. This went along perfectly with Ashwa's teaching in this unit. So this is where all this material comes from. So full credit to Ashwa, as everything I'm about to talk about is what I have actually learnt from him and this textbook. And you can also see here, this is the class that I was in when I was doing this unit. The really cool thing about doing an environmental science degree is pretty much most units you get an opportunity to get out on country, get your hands dirty, get in the bush, dig a hole, look at the trees, smell the eucalyptus. It's an absolutely wonderful experience at CQU and very, very hands-on. So although Ashwa's unit makes the foundation of this presentation today, there are so many other sciences that are applied to mine site rehabilitation. You pretty much need to know a little bit about everything, and even better if you specialise in any of these units. So these are the names of some of the units that I have completed in my environmental science and Bachelor of Science degree. Such a huge variety, which is absolutely amazing, but all of these really come together in rehabilitating landscapes as to mitigate the flow-on effects and manage the entire landscape, surrounding landscapes and waterways. Once again, if you're thinking of doing an environmental science degree or a Bachelor of Science degree, I absolutely recommend it, especially at CQ University. These are some pictures of some of my field trips. We've been out to Konomi Island and Whopper Island. Just such an incredible experience. As you can see, here I am, I dug a hole and I'm sitting in it. I'm at the boat ramp. You meet so many cool people. Here's one of my besties, Christina. It's just such an incredible experience on country, on sea, on water, and of course you make an enormous network of colleagues and friends. So before we get into rehabilitation, I'd just like to give you a little bit of a summary of Australia's ecological history. So we have what I call pre and post invasion or colonisation. And basically, when we're restoring or rehabilitating a landscape, we're restoring or rehabilitating it to what was there before the mine site. What we need to understand is that is actually not the original environment or landscape. Before invasion, Indigenous people managed Australia and managed the land and lived harmoniously with it. Post-colonisation, all the trees were torn down, all the old growth's gone, a lot of land clearing. This caused the water table to rise, a lot of soil and fertility issues. They really did make a bit of a mess of it. Whereas before colonisation and before invasion, this was an absolutely beautiful, pristine landscape. So you just need to kind of remember that. Rehabilitation itself is not aiming for that pristine landscape, but for a functional one where hydrology is happening, there is soil fertility, there are biogeochemical cycles happening, native species have been planted in the area, there is ground cover to reduce runoff, but we're just restoring it to, or rehabilitating it to what was, not what the environment truly was before colonisation. For anyone working on country, I really, really strongly encourage you to read Dark Emu. Please do, that is your homework. It will give you a really good idea and paint a bit of a picture about Australia before colonisation. And I think it is so important to understand that because Indigenous people managed this country right. And post-colonisation, this country hasn't really been managed that great. We're learning from that. We're doing a lot better now. We're getting our traditional owners back out on country. They are now making those decisions. They are managing their land, and that is a very good thing. But it is important to understand how much damage has been done to country. So please take the time to read Dark Emu. Young Dark Emu is here for any younger students. I definitely think anyone 15 years or older could definitely have a read of Dark Emu, and I would absolutely recommend it. So when I did this presentation for my STEM students, I did ask my class, have you been to a mine site? And what are the environmental impacts? And I had those students answer those questions. So I actually hadn't been to a mine site until I took a field trip with Ashwa, and my jaw dropped. Nothing can prepare you for physically standing in front of a mine site. It's ginormous. It's so much bigger than what it looks in the picture. There's no green. Everything's gone. Everything's dead. In these like open pit styles mines, everything's been dug up. It is just rock and soil and nothing else. And it's such a heart-wrenching thing to see. In central Queensland, we do have quite a few mine sites. You'll be driving through bush and eucalyptus, your acacias, melaleucas. It's all beautiful and green, and you'll come to a mine site and it's just completely gone. There's nothing there. And it's very, very eye-opening. So if you ever have the opportunity, definitely go to a mine site because it is incredible to see. It's heartbreaking to see, but it's really important to be able to fathom and understand what we're talking about when we refer to a mine site and just how much the environment has been impacted from that activity. So when we talk about mine site rehabilitation, we are talking about the 3 R's. And yes, this is straight from Ashwa. We are talking about reshaping, revegetation, and return of fauna. And I'll talk you through those in the next couple of slides. Reshaping and revegetation generally fulfills what we call rehabilitation. So basically, we want to see regreening. We want to see plants and trees. When we're seeing that, we're seeing rehabilitation. Restoration actually requires the return of fauna. So that is maybe the endemic animal species that were living there before the mining event. When we see the return of fauna, we know that we're moving towards a climax community, or that a climax community is pretty much being reached, and the landscape is returned to its original, which is again post-colonial state. Now this will take years and years and years and years. This will take 150 years. So when I'm out there restoring the landscape, I'm not actually going to see the outcome. It's the students that are in school today and my children and their children that's going to really see that restored landscape and the return of fauna. And we're talking marsupials and mammals and keystone species. So we're going to start off talking a little bit about reshaping. So what we want to do when we reshape is we're going to take it from picture 1 and get it to picture 2. And we're really going to think about the angle of the slope, because this greatly affects the amount of erosion and runoff that is happening in that landscape. So when we do that, we are aiming to store water in the landscape. We don't want it to leave the area. We want it to get in that soil profile because we're going to be planting seedlings and grasses and pioneer species in this area. That will be our next step. So we want to make sure that water is really being retained in the landscape. The other thing we're going to do is we're going to return the topsoil. We're going to create a functional soil ecosystem. So when I talk about a soil ecosystem, soil is very much a living thing. If you pick it up and you put it under a microscope, you'll see there's a heap of things living in there. They might be worms and the things you might think of off the top of your head, but there's also a lot of microorganisms, and they are absolutely essential to soil fertility. The other thing that we might see in our soil is some really heavy metals. and we're going to talk about how we're going to get rid of those later, but we absolutely need some nice healthy soil sitting on that landscape, and that's part of our reshaping. And like I said, once we've done that, we can go ahead and regreen the area, which means get those grasses growing and really kickstart that ecological succession. So we'll see our pioneer species coming through, which brings us into our next step. Okay, so our next step, once we have reshaped our landscape and we've got our beautiful soil down there, is to establish the native vegetation. And this will take some time because as we work through the stages of succession, we're going to start out with the grasses that we planted, and we're not really going to see our native vegetation taking off until 5, 15, 25 years. So we want to probably get some nice native grasses in there, some shrubs, some bushes. This is where Ash was the absolute pro as our botanist. He'll be able to give you a whole species list of what you should plant and where to really kickstart that ecological succession. And when we do that, we are providing stability to the site. We're seeing the return of our biogeochemical cycles and our nutrient cycles. So for example, our nitrogen cycle will be happening, a carbon cycle will be happening, as well, of course, as our hydrological cycle. Water's being stored even better now. We're seeing a lot less erosion, a lot less runoff. We're really starting to rehabilitate this landscape. So this is known as rehabilitation, and in America you might hear them call it reclamation. Obviously, as you can see, it does take a long time to see like a mature hardwood forest returned. We're talking about 150 years, and this is quite close to the landscape that we're seeing before the mining event. So it will take quite a long time to completely revegetate and rehabilitate a landscape. And the last thing we want to see happen is the return of fauna. And this is absolutely what environmental scientists aim for. When we have the return of fauna, we know that we have a functional ecosystem. There are resources and habitats available for the animals that once lived there, and they have returned to the ecosystem, which is great news. So when this has happened, we say that the land is restored, as it has been taken over by the native and endemic plant and animal species. So this is just one extra step above rehabilitation. What you'll find with mine sites though, this is not always necessary. Mine sites may only require it to be the landscape to be regreened or rehabilitated or revegetated, not necessarily restored. But this is what we as environmental scientists absolutely aim for. You might not know this, but in Australia we have had the biggest mass mammal extinction in the entire world. And yes, that is from colonisation. So we really need to stop and think about our little marsupials and our mammals, our little fluffy creatures. We want to really start looking after them. The koala is going extinct. The tree kangaroo is going extinct. There's a very good chance the STEM students' children will not ever get to see one in real life. So it's time to stop and really think about how mine sites can stop displacing these animals and how we can really start protecting them. So it's also really important that once that land is restored, it's handed back and managed by traditional owners, because they are going to take the very best care of that land. That is part of healing country and connecting to country. So once we have fixed up the landscape, and hopefully we've had our traditional owners along the way in that process, in that decision-making process, we hand that land back to traditional owners. That is what healing country is all about. Yes, this will take a long time and continual monitoring. So it's also important we have lifelong partnerships with our traditional owners when we are restoring these landscapes. So how we do this is a bit of a trick. Basically, we want to start at the beginning. What was the landscape like before the mine site, pre and post colonial? So we like to go out there and have a look around before any action happens on the proposed site and see what native species we have there. That's flora and fauna. Is there any remnant vegetation? Is there anything that just absolutely cannot be knocked down? The mines will often set a heap of offsets for what they're going to clear. We really need to know what is on that land, what is on that bit of country. So when we go to rehabilitate and restore, we know what needs to be returned. It is important to remember, though, that rehabilitating is just providing a functional landscape, not necessarily a pristine one. The landscape should be continuing through the stages of ecology. It does not necessarily need to be a climax community. There does not necessarily need to be fauna returned. Like I said, it's just essentially regreening or revegetating the area and hoping for the best. So the problem with that, though, is when we regreen and revegetate and there's some kind of catastrophic weather event like a fire, sometimes those systems will bounce back and sometimes they won't. But when we've really restored that landscape, you'll find that the landscape will be very resilient to fire, especially if there's those older growth eucalyptus trees there, and there'll be less devastation to the landscape. So in these pictures, you'll see these are the alleged after photos of rehabilitating a mine site. And just if you compare them to the ecological succession picture above, you'll see that this site here, the one that says after mining, is quite a young site. I'd expect that site to be maybe anywhere between 2 to maybe 5 years old. The site next to it that just says B, I'd say this would be an older rehabilitated site. I'd say that it'd be anywhere from 15 to 25 years old. Return of fauna, not necessarily in that first image. I wouldn't think so. You would definitely have, like, you know, your reptiles and your insects and things like that. In this second photo, yep, I definitely expect to see a return of fauna species. You'd definitely be having your birds, potentially some marsupials and mammals, but we're definitely not at a climax community. We're definitely not at what was there before the mine site. We're still a long way away from that. So the other thing with mine site rehabilitation is big ideas provide innovative solutions by applying environmental science to environmental issues. Do you have the next big idea? And our wonderful Professor Ashwa absolutely had a very, very big idea, and we're going to talk about that next. And that big idea completely changed how we really rehabilitate mine sites. So what I'm referring to here is phytoremediation. So phytoremediation is basically restoring the landscape and the soil in particular using plants. And Ashwa has done this over and over and over and over again. And I know I'm just not going to give these ideas justice to Ashwa's standards, but I'm going to briefly explain them to a year 10 level so that you can gather the concept of what Ashwa's done here, and it's absolutely brilliant. So what we're going to talk about is phytocapping, phytomining, and phytoremediation. So what Ashwa has done is he has used plants to restore the soil, restore the functionality of the landscape, while regreening and revegetating the landscape with these plants that he's using. So you can see in the picture he's got quite a bare landscape. He's planting his very selected plants and they're growing. And what is happening underneath this landscape is there might be a heap of waste that he's planting over the top of, or in this soil there might be a lot of toxic metals, and what these plants are going to do is they're going to suck up those metals, they're going to hyperaccumulate them, and then we're going to remove the plant, and those toxic metals have then been removed from the landscape. So Ashwa has a heap of papers you can read about this. So he used the Chinese brake fern to treat soil to remove arsenic from cattle dips. And then again, this was massive in Rockhampton. He did some phytocapping over our rocky dump to really stabilize that landscape. And if you're not familiar with the rocky dump, someone had a really brilliant idea to put the dump right on a waterway, the Fitzroy River. So it's a bit of an environmental nightmare if any of that rubbish escapes the dump and ends up in that waterway. So we really wanted to prevent that from happening, and Ashwa had the brilliant idea, why don't we just put some soil on it and plant some plants on it, and that'll fix the problem. And that's essentially what phytocapping is. So I'm just going to define these ideas a little bit better for you. So we're going to start with phytoremediation, and that's the big idea. And what phytoremediation is the treatment of pollutants, waste and contaminants in soil using plants to remove, degrade or stabilise the undersized substance, creating a functional ecosystem. So you can see that in this image here. We have our waste layer. So in Ashwa's case, that was the Rockhampton landfill. But of course, we can be talking about our waste rock at the mines. We're going to put our soil cover over the top, and then we're going to plant a beautiful tree, hopefully an Australian native, on the top. And that is going to stop leachate from leaching down into the soil profile and then obviously into aquifers and surrounding water bodies. And it's also going to stop the runoff and the erosion and just the general loss of the waste into the surrounding environment. And of course, at the same time, we're re-greening and re-vegetating the landscape because we're planting trees, which is brilliant. So phytocapping is essentially that idea. It's establishing vegetation over the layer of contaminated soil. It reduces water infiltration into the contaminated soil, reducing runoff and leaching of toxic chemicals through the soil profile into the groundwater and associated water bodies. The other thing we can do, or what Ashwa has done, is called phytomining. And this is such a brilliant idea. What this does is uses plants which hyperaccumulate particular metals from the soil. So when they're taking up the water from the soil profile, they're also taking up those toxic metals out of the soil. And that is therefore removing them from the soil, increasing soil fertility. What we'll do then, and why it's called phytomining, is we're going to harvest those plants from the area, or mine those plants from the area and then burn them. The carbon will burn and we'll end up with just the metal that that plant has hyperaccumulated into its leaves and shoots. So then we get to reobtain that lost metal from the soil. The metal is removed from the soil is therefore more fertile, and we can go ahead and continue revegetating and rehabilitating that landscape. So that's just some of Ashwa's work. I would definitely recommend, if you can, jump on our CQU profiles and you can type in any lecturer's name and it will give you a really good description of the lecturer themselves, but also all their work will come up, all their papers will come up. And if you have a little look through Ashwa's huge amount of papers that are on his profile, you'll see where he's done quite a lot of photo remediation and also quite a lot of landscape rehabilitation. So if you'd like to do some further reading, definitely check out Ashwa's profile and have a little read through those papers. And of course, you need to do your homework and read Dark Emu. So now we're going to move along to the quiz and the answers. So you should have taken notes throughout this session so that these are quite easy to answer. For those doing this activity at home, these are our questions. All of the answers are in the presentation. So who are the traditional owners of the land of which we study? Rockhampton is the Durrumbul people. Here on our coast, that's the Wapabara people. And in Mackay, where my STEM students were, that's the Uribara people. And it is so important that we always know and we always acknowledge whose country we're on. So that's my presentation, guys. Thank you so much for coming along with me. And yeah, that's just very, very basic mind site rehabilitation for you.